Here we go, folks. Math time. All right, yos. As you know, we had our Mario. We didn't have Mario. We had our DMR, our math review. That's what I wanted to say yesterday. I want to go over those with you. I do not have fancy little drawing tools, so I will just be clicking on the correct answer. Okay. It says read each answer and choose the best answer to the question in the story problem below. When we say the best answer to a question, I need you to understand that means there could be more than one, but we're looking for the one that makes the most sense. Okay. Kimberly baked a cake for her family. She cut the cake into 12 pieces. If she has 4 people in her family, including her, how many pieces of the cake will each family member get if the cake is split evenly? So there are 12 pieces, and there are 4 people in her family, including her. So that means I can count by fours until I get to 12. 4, 8, 12. I counted 3 times. So each family member would get 3 pieces of the cake. Number 3, how many unit fractions of the bottom model will it take to equal the top model? Well, I have 6 on my bottom model, and on the top I have thirds. 2 of the 1/3 pieces are gray. They end right here. So I need to look at everything on the left of where they end to see how many there are. I would need 1 1/6, 2 1/6, 3 1/6, 4 1/6 pieces to equal 2/3. So I would need 4 unit fractions. A lot of you selected 2/3. The question is not how much is shaded on the top model. The question is how many unit fractions of the bottom model would I need? Okay. Any questions on that? Yes, Levin.
It wasn't on the DMR, but it was something on an assignment from yesterday. It was an assignment for seasons. It's saying that I did, but I did it.
All right, get over. I have to take care of that later, okay?
Okay.
Yeah, question about DMR right now?
So, I didn't get that question because I chose 6 because I thought we were talking about like how many in all is under the line, not how many to the highlighted.
Gotcha. So yeah, when it's asking to equal the model, we want to look at the amount that's shaded in that model because that model is showing us 2/3. So we need to have the same distance here. Okay. Great distinction. All right, choose the comparison sentence that best matches this model. So on our top, we have 2 pieces of the 3 total that are shaded. So this is 2/3. On the bottom, we also have 2 pieces, but there are 5 total. So this is 2/5. So I'm dealing with 2/3 and 2/5. They are not equal to each other. These 2 pieces are not equal to the other 2 pieces. 2/3 is greater than 2/5. That is true. 2/3 is a longer portion of red than the 2/5 is. And 2/3 is less than 2/5 is not true. So 2/3 is greater than 2/5 is your correct answer. Choose all that are true about this equation. We have the equation 325 subtract 98. 325 subtract 98 is equal to 227. Okay, 227. So we have right here the difference is 227. We know that this is worth 2 points, so I should be selecting 2 because it says all that are true. The other statement that is true about this is that you use addition to check the accuracy of the answer. I have 325 subtract 98. That equals 227. I can check that with addition, by taking 227 plus 98 and seeing if it equals 325. And it does. So you can always use opposite reactions, or I apologize, opposite operations to look at the truth of a statement. Leah, a question.
Are we not allowed to use calculators?
That's correct, but I don't have drawing tools, so I was showing you the best way that I know how. Okay. All righty. Next up, we have compute to find the answer 935 plus 58. You should have typed the answer 993. 5 plus 8 is 13, so we've got to carry that 10, put down our 3 ones in our ones place. 1 10 plus 3 tens is 4 tens. 4 tens plus 5 tens is 9 tens, so we've got a 9 in our tens place. And then we have our 9 plus nothing, which is 9. So 993 should have been the only thing that you typed. Choose the fraction that matches the model. We count spaces on number lines. There are 1, 2, 3 spaces on the whole number line. Our arrow is pointing to the second space. So 2/3 is your correct answer there. Okay. Alrighty-os. Any remaining questions about DMR? Levin.
Can I go to the restroom?
Kiddo, yes, I need you to focus on DMR, please. Terrence, question about DMR.
So, will we be able to use calculators when we get in a higher grade?
So here's the deal, guys. Calculators are a fantastic, wonderful tool, okay? Calculators are not bad, but you need to make sure that you understand how the math works, okay? It's a scary world when we just let computers do things for us. And also, it's helping you understand future math. So if you don't understand how to work the ones, tens, and hundreds places, you don't know why math works in the real world. You wouldn't understand pennies and dimes because you never practice with the ones and the tens, okay? So calculators aren't bad. It's not that we don't want you to use them because it's cheating or it's bad. It's because we want you to have an understanding, okay? So yeah, you will, as you get older, you can use calculators when you know how to do
Miss Susie, you paused.
She's frozen.
I know, it's okay, guys. Hey, why don't you go ahead and go to Seesaw and pull up your assignment?
She hasn't released it.
Okay, hang on just oh, she's unfrozen.
Okay, yay, thank you. Okay, yes, here we go. All right, so I closed out some tabs. I think it was because I had those tabs open when I was trying to call you guys. Every time I do that, slows down. All right, we are going to continue our conversation about equivalent fractions. And in order to do that, I'm going to watch a video that you guys saw yesterday because it's good exposure with equivalent fractions. And the more you see them, the more your brain is going to memorize those relationships. So we're going to take some time to watch this again, okay? The brain pop about equivalent fraction. And after we do this, we will get right into the work. Here you go.
This sandwich has 4 equal parts. You took 2/4 of the sandwich. That's the same as 1/2.
Where do I go?
Equivalent fractions are equal to the same amount, but use different numbers. What are some fractions that are equal to 1/2? Becca and Tasha are sharing a sandwich, and each gets half. Their sandwich has 6 equal parts. So each person gets 3 out of 6 parts, or 3/6 of the sandwich. You can draw pictures to help you see how fractions are equivalent. Mike and Brian are sharing a pizza. Their pizza has 8 equal slices. So each person gets 4 out of 8 slices, or 4/8 of the pizza. 4/8 is equal to 1/2. Moby. On this rectangle, 5 out of 10 equal parts are blue. If you look at the rectangle a slightly different way, you can tell that half is blue. So 5/10 is also equal to 1/2. What are some fractions that are equal to 1/4? 2 out of 8 parts of this quilt are yellow. That means 2/8 of the quilt is yellow. If you look at the quilt a little differently, you can see that 1/4 is yellow. So 2/8 is equal to 1/4. What fraction of the tiles is green? 3 out of the 12 tiles are green, or 3/12. You can also see that 1/4 of the tiles are green. So 3/12 is equal to 1/4. What are some fractions that are equal to 1/3? It's time for dessert. This cake has 6 equal slices. 2 slices have candles. So 2/6 of the cake has candles. If you look at the cake in a slightly different way, you can see that 1/3 has candles. So 2/6 is equal to 1/3. Did you eat the candles too? There are 12 eggs, but 4 of them are cracked. 4/12 of the eggs are cracked. If you group the eggs differently, you can see that 1 out of 3 equal groups are cracked. 1/3 is cracked. So 4/12 is equal to 1/3. You're trying to glue the eggs back together? Okay. Equivalent fractions can show the same amount using different numerators and denominators. It can be a little confusing, but you can draw pictures or build models to help you understand. Not that kind of model.
All right, so equivalent
Right about
fractions,
it.
understanding that fractions are the same size overall, even if the pieces are different. Okay, fractions are the same size overall, even if the pieces are different. Today, we're going to take a look at continuing to practice with equivalent fractions on different models, circle models, rectangular models, number lines. We're going to do a lot of back and forth. Okay, we're going to do a model together. I'm going to send you guys to work on some in breakout rooms. We'll come back and review, and we'll repeat that. We'll do a different model together. We'll go into some breakout rooms. We'll come back to review, and we'll go on to the next model. Okay, so lots of back and forth today. Before we start that, Mr. McKinney has prepared a video for us about pizza just in time for lunch to get all of us nice and hungry, looking at equivalent fractions and proving that they are the same size in the total, even if the pieces are different. Okay, here's what he would like us to know.
Take a look at this delicious cheese pizza. That is one whole pizza. There are no slices. Now there is one slice cut into 2 pieces. But Is it still the same size whole pizza? Your answer should be yes. Even though I put a slice in the pizza, I didn't take away from any of the pizza. I didn't add to it. It's still the same size, but now it's just 2 smaller pieces instead of 1 giant piece. Now I cut it into 4 pieces, but it's still the same size whole. I'm just getting smaller pieces. And my pieces are still getting smaller, but again, my whole pizza is still the same size as it was from the very beginning. On the left, I have 1, 2, 3, 4, 5, 6, 7, 8. Each piece represents 1/8. And if I have all 8 out of 8, that is the same as 1 whole pizza. So if I still have all of my slices left, both of these pizzas are the same size. If I ate 4 pieces out of the 8, my fraction would be 4/8, which would also be the same as 1/2. This one is just cut up into smaller pieces. 4 is half of 8. I ate half of the whole pizza, and if we only cut 2 slices, 1 is half of 2. I ate half of that whole pizza. Notice that my bottom number on this side is 8, so that tells me that there are going to be 8 pieces total. My bottom number, my denominator, over on this side is 2, so that tells me there are going to be 2 pieces total. Even though the fractions are different, they can still be equal to each other. If I want to see if 4/8 is equal to 1/2, without looking at another picture, I can look right at my denominator, 2. I want to see if I can split this pizza up into groups of 2. And I can do that by taking one group of 4 in each, and another group of 4. So I took 2 groups of 4. So that tells me that if I ate this side, I ate 1 out of 2, which is known as 1/2, which is also known as 4 out of 8.
All right, so we're looking again at those models, and that's what we're going to do together today. Today, we're going to look at some models together, then give you some time to practice. We're going to look at different models and then again, time to practice, okay? Your activity has been unlocked to you, so if you guys would please go to Seesaw and click on your light bulb to refresh, you'll see the activity load up called Equivalent Fractions Practice, okay? Again, we're going to go back and forth together today, alternate working with your teacher and a partner as directed on slides 1 through 13. So click on that add response for me. Slide 1 is our goal. Here with your teacher, we're going to look at these models and fill in the missing information. Okay? Give you a second to get there. Alrighty. So looking at our first model, we can see that there are 6 pieces. 1, 2, 3, 4, 5, and 6. Our denominator is already showing a 6. The question is, how many are shaded? There are 1, 2, 3, 4 that are shaded. So our numerator is going to be a 4. This is showing us that 4/6 is equivalent to 2/3. Okay. Now, this is often difficult to see. So one thing that I like to teach kids is to kind of draw the borders. And here's what I mean by that. I'm going to put a line going down the section that is shaded and that is not shaded so that I can see what size piece is not shaded. So go ahead and do that same thing. Trace those edges of what is shaded and what is not shaded, and then do the same thing over here on the circle model that's next to it. So when we do that, we can see that the same size and shape of piece is missing. We've got this kind of very widely opened greater than symbol. And that's one way that I can very easily see that, in fact, even though the pieces are smaller on the 6, the total amount of shaded is the same. Now we're going to come over here and take a look at these circle models, and we can see that we have 2/4 because 2 pieces are shaded and there are 4 pieces total. This over here is halves, and we can see that 1 is shaded, so our numerator is a 1. 2/4 is equivalent to 1/2. And again, I like to just trace that line that's separating the parts that are shaded and the parts that are not shaded. And in this case, it's going straight up and down.
We have to.
And over here as well, it's going straight up and down. So what that does is that helps my eye to very easily see that the same amount is shaded, even though the number and size of the pieces are different. Okay. When we're looking at the whole, the total, the same portion is shaded. All right. Are there any questions on these two before I release you to work in breakout rooms? Any questions? Okay. So I'm getting ready to put you into breakout room partners, and you are going to work on slides 2 and 3. So slide 2 says in your breakout room, slide 3 says in your breakout room. You're going to do exactly what we just did. Fill in the numerators and prove that they are equivalent. Okay, fill in the numerators and prove that they're equivalent. I'm going to give you about 2.5 minutes for this. You do not need long. All right. Okay, here you go. Alrighty, here is what you should have found. On slide 2, you should have found that 2/8 is equivalent to 1/4. If you trace those edges, you can see that that kind of rounded triangular piece is the same size. For 1/3, you should have found that it is equivalent to 2/6. Again, we've got that kind of dramatic less than symbol with the wide or opened mouth there. And it's the same size piece inside. On slide 3, you should have found that 6/8 is equivalent to 3/4. Again, if I trace, I can see that that rounded triangular piece is missing on each of my circles. And then 1/2 is equivalent to or the same as 2/4. Okay. All right, let's take a look at slide 4. Slide 4 says with your teacher. So now we're going to take a look at number lines. The question is 1/4 equivalent to 2/8? Go ahead and take a line and connect those two dots, 1/4 and 2/8. We can see that those are in the same place on the number line. They stop in the exact same place. So yes, 1/4 is equivalent to 2/8. The question is, how do you know? Let's add a text box to explain how we know. The dots are, make that a little bit longer. Plotted at the same distance. The dots are plotted at the same distance. That's how we know that they are the same size. They're that same distance away from 0. Okay. You are getting ready to do the same thing with number lines now with your breakout room. Again, there are 2 number lines for you to read with fractions on them, and you're going to determine how you know that they are equivalent. Okay, so we've done 1/4 and 2/8. You're going to do slides 5 and 6. Oh, I apologize, just slide 5. Just slide 5 with your breakout room. Is 1/2 equivalent to 5/6? How do you know? All right, I'm going to send you in there for you to have that conversation. It's one problem, so I'll give you 1 minute. 11, a question.
Can you put me with Justin?
I cannot. Breakout rooms are set and they're going to stay the same. Okay, if you solved the slide correctly, you should have found this answer. If you did not solve the slide correctly, feel free to fix it now. Is 1/2 equivalent to 5/6? The answer is no. We can see that 1/2 is much shorter than the distance all the way to 5/6. So no, these are not equivalent fractions because they are not the same distance from 0. Other acceptable answers might have been because 1/2 is shorter or because 5/6 is greater. Anything of the like. Okay. Let's take a look at slide 6. Slide 6 says, with your teacher, use the number lines to find a pair of equivalent fractions between 0 and 1. So looking at these number lines, I'm going to use common sense, and I already see 2 fractions that are in the same place. They line up right there. I don't have fractions that line up with 1/6, 2/6, 4/6, or 5/6. Okay, I do have fractions that line up with 3/6. So I'm going to go ahead and move my dots to plot the 2 fractions that line up here. So let's grab this red dot and let's put this at 3/6. Let's grab that next one and let's put it at 1/2. We know that equivalent means equal sized. So these fractions are equivalent or equal sized because they line up at the same distance. So when we read our number lines, we can see that this is 3/6 and 1/2. Okay, 3/6 and 1/2 are equivalent fractions. Question is, how do you know? We know the same way we know when anything is equivalent. The fractions are the same sized part of the whole. The fractions are the same sized part of the whole. So not the same sized pieces, but the same size part of the whole. I'll put that in the chat. Feel free to copy it there since we're a little bit shorter on time today. So the fractions are the same sized parts of the whole, the same distance from 0 to their endpoint. Okay, you're going to solve problems just like this in your breakout rooms on slides 7 and 8. Slide 7 asks for you to do exactly what we did. Drag the dots to create equivalent fractions. You might notice that there are some hints given for you with the denominators. Okay? And then how do you know? On slide 8, you are asked to drag the dot to the matching equivalent fraction on the bottom. So I notice that 2/8 is purple, and here's a purple dot by 2/8. I'm going to drag it to the fraction that it lines up with, and then I will write that fraction on the line here, 1/4. Okay, so in your breakout room, you're going to solve slide 7 and slide 8. Time. Alrighty, folks. If you completed your work correctly, this is what you should have had on slide 7. 3/6 and 4/8 are equivalent fractions. Your explanation might have been a little bit different than mine, but as long as it explains how you know they are in the same location or the same distance or the same size part of the number line. I said they're both at the halfway point because I recognize that this is half of a number line. Oh, it's taken my highlighter away. Here we go. Oh, it's because that thing is still open. Let me close it. Nope. Go away. Oh no. What did I do? Okay. Well, hopefully it works. All right. No, it's not gonna work. Oh, great. Hold on, friends. There we go. Okay, awesome. Slide. Oh no. Okay, and then slide 8. This is what you should have found here on slide 8. With your breakout room, you should have found that 2/8 is equivalent to 1/4. 4/8 is equivalent to 3/4. And 6/8 is equivalent to 3/4. So we have these lined up here. We can see that they are in fact in the exact same location on the same sized whole number line. Okay. Slide 9 says with your teacher, but there is a video there explaining that. So I'm going to ask you today during your independent work time to watch this video on slide 9 explaining the work, and then complete slide 10. Okay. Slide 11 is showing you the tool that we used yesterday. There's a link right here to get you directly to it. And you're going to use that tool to take screenshots of different fractions today, proving that they are equivalent. So you're going to create 2/8 and 1/4. You're going to let me know if 2/8 is greater than, less than, or equal to 1/4. And you will also be pasting a picture of it here, of the work that you create on that screenshot of that website that we used yesterday. Okay, so the rest of these slides are going to be independent work today. Again, slide 9 does say with your teacher, but there's a video recording there of the teaching, so you are fine to do that alone. So the rest of this is what you will be completing today. Slide 17 is a reminder to you that you are expected every day to spend 15 minutes on Zearn. So you need to practice your fractions on Zearn, and then if you have extra time, you can get onto Prodigy. Okay, that Zearn is an expectation just like Lexia is.